Hi students, in this lecture I am going to discuss about software design unit 3. With this topic we are going to start unit 3. So, let us start the class and first we will discuss what is meant by a software design. So, software design is a crucial phase of the software development life cycle that mainly focuses on the solution to be developed for the project. So, it begins once the business needs, customer requirements and technical considerations are available in the SRS document. So, hence we can say that software design is a process of describing the blueprint or sketch of the final software product in the form of design. So, it behaves as a software design behaves as a blueprint or sketch which describes the entire software product need to be developed, right. So, here the software design exists between requirements engineering and programming phase. That means, first we will collect all the requirements from the client and we will analyze that requirements, and after analyzing the requirements we will prepare a SRS document with a valid requirements. So, after preparing the SRS document, then we will go for designing phase where we are going to design entire software product, final product to be developed, and after that we will go for the programming phase, that is coding phase. So, here requirement software design exists between requirements engineering and programming phase in software development life cycle. Here the software design process basically consists of 3 design phases or 3 design levels, that is architectural design, physical design and detailed design. There are 3 design levels, or we can say that design phases in designing the software. Okay. So, first we will discuss about architectural design. In architectural design, it starts, it takes as the SRS document as an input. So, here in architectural design, it is an external design which considers the external behavior of the software product, right. So, here we will consider all the external behavior of the software product. So, external behavior of the system is concerned with people who control it, or server machines, centralized database, security aspects, etc., right. So, the external design considers the architectural aspects related to business like technology, major data stores, structure of data and modules to be developed, reports need to be generated, and performance criteria and high level process structure of the product. So, it begins with requirements engineering and continues to produce a high level architecture, right, or blueprint of the product. Let us take a small example. Here software design is similar to software designing is similar to designing a building, right, designing a building. So, during the architecture, so building also we will do it in 3 phases. So, what we are going to be do in architectural design. So, during the architectural design, the builder decides the architecture, that is whether the building has to be constructed in multi-store or bungalow or a row house, etc. And here also he considers the floor plan sections like and elevations to determine the space dimensions during the architecture section. Thus, a systematic design is produced at this stage. So, now coming to the software design. Coming to software design, here we are going to design the external behavior of the software need to be developed. So, here we use some architectural styles in developing the external behavior of the software. So, that architecture we have so many architectural styles are there. For example, client server architecture, layered architecture, data centered architecture. So these architectural styles play an important role in producing the external design of the software. And we have so many types of architectural styles are there. I have already mentioned that data centered, layered architecture, client server architecture, and each architecture has the different way of architecture mechanisms or characteristics for developing the external architecture of the behavior. Then we will go for the physical design. So next phase is physical design. So here physical design is a high level design or structural design which is concerned with the conceptual view of the system. So here physical design mainly focus on the conceptual view of the system, like identifying the modules, decomposing the modules into sub modules, interconnections among the modules, data structures and the data stored in the system. So entire detail about the system is going to be designed in physical design, that is nothing but conceptual view of the system. Coming to the building architecture, what is going to be done under physical design. So in physical design, he is going to design the complete detailed design about physical design, detailed design like selection of materials, engineering items need to be have, and the main aim is to finalize all the design decisions before proceeding with the building construction. So the engineering issues such as structural system, that is structure of individual house or individual house for the location of rooms, galleries, stairs, and also heating and cooling of the system, lighting of the system. So all etc. all such issues are going to be finalized in physical design, right. And here coming to the software design, there are so many design methodologies are there. With the help of that designing methodologies, we will design the physical design, we will design the conceptual view of the software. Example like a structured design, object oriented design, Jackson structured design. So some types of design methodologies are there. With the help of that design methodologies, we are going to design the physical design of the system. Then we will go for the detailed design. So here detailed design is the algorithmic design of each module in the system. So in physical design, we will design how many modules are modules are to be there, and decomposition of the modules, right. So that modules, for each module algorithm is going to be developed. That algorithm is going to be developed under the detailed design, and this detailed design is also called as logical design. So the logic is going to be developed here for each module. So the detailed design concentrates on specification of algorithms and data structures for each module, and interrelationships between the modules, etc. So the detailed design can be directly converted into source code for programming language. So next, after software design, like in this figure, after designing the software, then we will go for the programming, then we will go for the coding. So after the detailed design, after we have developed all the algorithms for each module in the system, each module of the project, then we can directly go for the coding phase. With the help of, by choosing some programming languages, we directly develop the source code with the help of this algorithms developed in this detailed design phase. So here how the algorithm is going to be developed is that here the algorithm is written with the help of a structured language, structured English, or pseudocodes are generally used for writing the specifications of the detailed design. So coming to the construction of the house, what we are going to done under the detailed design. So the builders prepare a detailed design in which construction drawings and written specifications are put together before starting the construction work. This may include dimensions of the floor plans, selections, engineering plans, electrical, mechanical, structural and civil engineering plans, landscape plans, final interior design plans, energy report, specifications of materials, methods of construction, all are going to be discussed under detailed design, where the complete entire structure of the means the constructors will get a clear understand about what to be done. Then they are going to start the construction phase. Right. So, here also same, coming to the software design, in detailed design we are going to develop the algorithm for each module designed in the physical design phase. Then after writing the algorithm, then we can directly go for the coding phase. Okay. So, this is software design process. So, we have 3 phases: architectural phase, physical phase and detailed design phase. So, in architectural phase we are going to design the external behavior of the system, and in design phase we are going to develop the conceptual view of the system or conceptual view of the project, and in detailed design we are going to develop algorithms for the entire system. So, in software design, the input is a SRS document. With the help of that SRS document only we will design, and the output is going to be algorithm by which we can develop the code. Right. So, this is software design process, and next we will see the characteristics of a good software design. So, the quality of a software design can be characterized by the application domain. For example, if we take the real time software, we will focus more on effectively and reliability issues, whereas academic automation software will concentrate on understandability and usability issues. Right. So, the desirable characteristics that a good software design should have as follows, like correctness, efficiency, understandability, maintainability and so on. So, first we will see the one of the good characteristic need to be have to for a good software design, that is correctness. So, a design is said to be correct if it only if it is correctly produced according to the stated requirements of customers in the SRS. So, when we will say the design is very correct means all the requirements of the client, first we will collect all the requirements and we will analyze and we will prepare an SRS document. So, what all the requirements that are present in the SRS document has to be present in the design. So, then only we will say it is a correct design. So, it should fulfill all the functional features, satisfy all the conditions and follow the guidelines given by the customer. So, a correct design is more likely to produce accurate outcomes. If we design correctly, then we will get a good output. If we did not design correctly, means if we missed some of the requirements of the client, then then the outcome will not be that much accurate. Next characteristic is efficiency. So, the efficiency of a design is concerned with performance related issues. For example, if we take for example optimal utilization of resources. So, the design should consume less memory and processor time, and we should develop a good design. Okay. If we use less memory and if we use within less time, if we have designed, then it is said to be more efficient. Right. So, the design should consume less memory and processor time. So, software design and its implementation should be as fast as required by the user. So, it should be as fast. If we take more time, then we cannot say it is efficient. If we prepare the design within the specified time given by the user, with less memory and using less resources, then we can say it is a efficient software, good software. Next we will next important characteristic is understandability. So understandability means in a design it should be easy to understand what the module is and how it is connected to other modules, what data structures are used, and its flow from one module to another module, and flow of information between the modules. So it has to be clearly given. Okay, how many modules are there, how the data is going to be flow between one module to another module, what are the relationship between the modules, everything has to be clearly seen in the design. So by seeing that design, programmers can easily develop the code. Right. So documentation of a design can also take it more understandable. So understandable design will make the maintenance and implementation tasks also very easier. So next characteristic is maintainability. So maintainability, it is one of the difficult and complex design, would take a larger time to be understood and modified. So therefore the design should be easy to be modified. We have to maintain it regularly, we have to maintain changes that occur while developing, right. So it should not, and it should not have unnecessary parts, and it should be easy to migrate it into another platform. So we can if at all, if any changes, if any technological advancements occurred while developing, or if any advancements in updations in softwares may occur, then we can we have to see that it has to be it has to be easily migrated into another platform. Okay. So next is simplicity. So the main goal of the designers is they has to develop a software more simply. So a simple design will improve understandability and maintainability. If we develop a simple design, then it can be easily understandable and it can be easily maintained. So introducing a simple design is rare, because a design follows certain steps and criteria. Still the designers always think that we are developing a simple software. They always think to keep it simple rather than make it complex. And next characteristic of a software design is portability. So portability means here we how we can say portable means yes, the external design mainly focus in the focus on the interface, business and technological architectures. So these architectures must be able to move a design to another environment. So we use different types of architectures while designing the software. So these architectures must be able to move freely into another environment. This may be required when the system is to be migrated from one platform to another, if at all platforms may change. So if platforms are changed, if we use in all of a sudden if we use different platforms, then it has to be migrated easily. So this is one of the important characteristic for a good software design. And last one is reusability. So here the software design should be standard and generic, so that it can be reused for different types of for similar type of projects which may come in future. So the design has to be reused for similar kinds of projects which may come in future. So if we reuse this software design for another software, then it is said to be a good software design. So these are all the characteristics need to have in